Hello guys, so we are going to continue the discussion with respect to statistics. Now we are moving towards the descriptive statistics content, and in this video we are going to discuss about measure of central tendency, a very important topic altogether. First of all, we'll go ahead with the definition. Then again, we will be discussing what are the different types of measure of central tendency that we specifically use. And with respect to that, we'll see multiple examples. So first of all, with respect to the definition, so here you can see measure of central tendency are statistical metrics that describes the center point of a data set. They provide a single value that summarizes a set of data by identifying the central position within a data set. Let's say I have a variable called as ages, okay? And this has a lot of values like 24, 32, 12, 48, 16, 20, right? Now, if this is my data set, I can use measure of central tendency to calculate the center point, or we can also identify the central position of this particular data set, okay? Because whenever we try to draw this data set in some kind of distribution, so this is a kind of distribution over here, we'll discuss more about it. Now in this distribution, the central region is basically identified by this measure of central tendency. What are the different types of measure of central tendency that we use? That is nothing but mean, median, and mode, okay? Now let's go ahead and discuss about mean, median, mode, and we will be going ahead and discussing about it step by step. And again, there I'll also be mentioning some of the points that you may have not probably thought before, right? So with respect to this mean, I know people will think, hey, just go ahead and calculate the average. No, you also need to define some important properties inside this, okay? And that is what I will be covering. So first of all, let's go ahead and understand about what is mean, okay? So again, with respect to the definition, mean is the sum of all values divided by the number of values. Now you know that we have already discussed about population and sample, right? So even mean also I would like to consider with respect to two terminologies over here. One is nothing but population mean, which is mentioned by mu, okay? So we specifically use something called as mu, and the other one is something called as sample mean. Okay? And this we can use it as x bar, okay? So here I'm giving two different notation just for your understanding. Now with respect to this population mean and sample mean, I am using this mu and x bar symbol, but understand population are usually given by a symbol. Whenever we take a population data, it is given by this capital N value, and similarly whenever we use sample, this is given by a small n value, okay? And remember, this n will always be less than or equal to capital N, okay, since sample is a subset of population, okay? Now, in order to calculate the population mean, so let me just go ahead and write the formula. As you know that I've already told sum of all the values divided by the number of values. So here we can go ahead and write summation of I is equal to 1 to capital N x of I, okay, divided by n, okay? What x is? X is a random variable. So here x is a random variable. We'll discuss about this, what exactly is a random variable, okay? Further, probably after a couple of videos, you'll be seeing what exactly a random variable is all about, okay? But just to talk about, let's consider one basic example, and then you will be able to understand. Let's say I have a random variable x, and this x is having values like 5, 8, 12, 15, 20, okay? So I have this random variable which has all these values. Here capital N, when I say, it is basically talking about what are the total number of values over here, 1, 2, 3, 4, 5. So over here, my population data is 5. I'm considering this as my population data. Understand, in a real world scenario, the population data will not be this much small. The reason why I'm talking about population mean and sample mean, because both of them will have a different formula. Okay. And it is important for you all to understand this also. See, sample mean will not have a different formula. I'll talk about it because in after this particular topic, we'll be also talking about measure of dispersion. And there also we will talk about population variance, sample variance, and many more things. Okay. So in this particular case, let's consider that I have used n is equal to 5, which is my population size. Okay. And I know population will not be this much small, but just for an example, I'm using it so that we'll be able to solve the problem. Now, in order to compute the mean, we will go ahead and write 5 plus 8 plus 12 plus 15 plus 20 divided by 5, right? And this will be nothing but 60 by 5, which is equal to 12. Okay. So 12 is the mean. Now, what does 12 basically indicate? 12 indicates that it is the, you can basically say it is the center point of this entire distribution. Okay. Similarly, if I really want to go ahead and compute my sample mean, we give it as this notation, x bar. Here also I will be using summation of I is equal to 1 to small n. Okay. And then here I will be having my x of I divided by small n. Okay. So this n is nothing but your sample size. This capital N over here is nothing but your population size. Okay. And this is important for you all to understand. Perfect. So I hope you have understood about the population mean and sample mean. And I hope you have understood the differences between them. Okay. Here we use the sample value. Here we use the population value. Perfect. And again, the calculation will be almost similar depending on the sample data. But let's go ahead and discuss about some of the important characteristics. And these characteristics are really important. The first characteristics is that mean is usually affected by extreme outliers. Okay. Extreme outliers. What exactly is this outliers? We will talk about it. Okay. And usually this is used for, mean is used for interval and ratio data. Interval and ratio data. I hope everybody knows about what is an interval and ratio data. We have already learned in the measurement of scale, right? Now, what does this extreme outlier mean? Let's consider I have a random variable x. Again, what is a random variable? Don't worry, I'll just discuss it in a couple of videos. Just consider that random variable I'm considering, it will have some set of values. Let's say I have values like 1, 2, 3, 4, 5. Now, if I really want to calculate the mean, so mean will be nothing but 1 plus 2 plus 3 plus 4 plus 5 divided by 5. So it is nothing but 6, 10, 15. 15 divided by 5 will be 3. Okay. Now, what if inside this random variable, I add one big outlier. Outlier basically means it is a number that does not belong to this distribution. Okay. So let's say I go ahead and write like this, and I go ahead and write 100. Now, if I have 100, if I go ahead and calculate the mean, it will be 1 plus 2 plus 3 plus 4 plus 5 plus 100 divided by 5. So now it will be 6, 10, 15, 115 divided by 5, which is nothing but 5 ones are, and this will be, 5 twos are 23. Now here you can see, because of this adding of this outlier, your mean completely changed from 3 to 23, right? This is my distribution. Does this indicate, does 23 indicate the central mean or the central number? No, right? It needs to be somewhere around this 3 or 4 itself, right? Because maximum numbers are present within this distribution 1 to 5. And this 100 is a very big outlier. So that is the reason we say that whenever we use mean formula, it usually gets affected by extreme outliers if this outlier is present in our data set. Okay. If this outlier is present in our data set. Now, what is the one way is that we can remove the outliers. Okay. We can remove the outliers and then we can probably calculate the mean. That is one way, right? But usually we don't go through that particular way. Why? Because every data point that we have in our data set, it plays a very important role, right? So removing a data point will additionally cause loss of information, right? So it is better that we try to find out a different way to calculate this central tendency, okay? And that is where we use something called as median. So second one that we are going to discuss is something called as median. Now, what is median? So here, in order to just define a definition, median is the middle value in a data set. Okay. And this value, when you will be able to find when the values in the data set are arranged in ascending or descending order. It needs to be arranged in either ascending or descending order. Okay. So let's see this. Okay. I will take one example now. Let's take the same example. Okay. So here, let's take X is my random variable. 1, 2, 3, 4, 5. Right. Now, in this data set, let's say X. First of all, before calculating mean, we need to calculate how many number of elements are there. So here the number of elements is 5. Then we will check whether 5 is odd or even. So 5 is definitely odd. If it is odd, we go ahead and find out the middle element. So middle element is nothing but 3. So here my median is actually 3. Okay. Median is actually 3. We are just trying to find out the middle number. Now what I will do, I will go ahead and add one outlier. So let's go ahead and add 1, 2, 3, 4, 5, 100. Okay. Or let me do one thing. Let me jumble this entire words also, values also. So let's say I'll write 3, 4, 1, 5, 2, 100. Now, first of all, what we do over here, we basically change this into ascending or descending. So ascending will be 1, 2, 3, 4, 5, 100. Now what we have done over here, we have added a big outlier. Now we'll see whether this outlier will affect your median or not. Now in this scenario, I need to find out the middle element. Now middle element over here, first of all, we'll go ahead and see how many number of elements are there. So the number of elements is equal to 6. 1, 2, 3, 4, 5, 6. 6 is even this time. Now if 6 is even, what we do, we take the central 2 elements, right? Because this side also equal number of elements will be there. That side also equal number of elements will be there. Then we will take both of them. We'll take the central elements and then we will calculate our median. Now this time the median will be calculated by 3 plus 4 divided by 2. We are just going to take the central element and we are going to calculate the average. So here you'll be able to see that I'm getting the value as 3.5. Now see one very important difference. Before 100 was not added, we were getting the median as 3. Now 100 has got added, and here you can see that there is a minor change in median. Before it was 3, now it is 3.5, right? So you can probably see the exact difference over here, and you'll be able to see that how median is not getting impacted by outliers, right? So over here, in the case of even, median is the average of the middle numbers, okay? In the case of odd, we can directly pick up that. So let's go ahead and write the characteristics, important characteristics. So one important characteristic is that it is not affected by extreme outliers, right? The other one is that this is used specifically for ordinal, interval, and ratio data, right? So this kind of techniques of finding the central tendency is used for ordinal, interval, and ratio data. Not for the first one, which is nominal, because that is completely categorical or It is also, you can also say it as it is qualitative. Okay. Now coming to the third type, okay, which is basically called about mode. Because for qualitative also we need to have some way, right? So the third technique is specifically called as mode. Now in the case of mode, first of all, let's go ahead and see the definition. The mode is the value that appears most frequently in a data set. Most frequently in a data set. Okay. And here, that is what mode is all about. Okay. Here, the mode is the value that appears most frequently in a data set. Okay. So let's say if I have a data set, let's say I have elements like 2, 4, 4, 6, 7, 7, 7, 9. Now, if you tell me to calculate the mode, just go ahead and see which is the most frequent element that is probably most frequently occurring element in this data set. The answer is 7, because here you have 3 times, right? 3 times 7 is basically present. So this is your most frequent value, right? Now in different problem statement, okay, you may have multiple modes. So let's say that I will take another data set. Here I'm just going to go ahead and give this. Let's say I will go ahead and add 3, 5, 5, 6, 6, 8. Now in this case, your mode 2 times you can see 5 is present, 2 times 6 is present. So your mode will be 5, 6. And this is basically called as bimodal. Okay. So you can have more than one mode. Okay. So this is your bimodal. So I will go ahead and write this. This is nothing but bimodal. Okay. Similarly, you may have multimodals also. It is up to you. Okay. Like how many number of modes are there? Now, what are the characteristics with respect to this? Okay. So let's go ahead and discuss about the characteristics. I've defined the above characteristics again here also. Since it is, we are working on most frequently occurring elements. So this is not affected. This is not at all affected by extreme values or outliers. Okay. Second important point will be that this is used for all the 4 scales. That is nominal, ordinal, interval, and then ratio data. So all the 4 scales you can specifically use this. Okay. But for my experience sake, you can definitely use this in nominal, right? All the other one, you cannot use it because we have already discussed it, right? Now, I really want to give one very important point, like which measure to appropriate, like which to choose, you know, when we should basically use mean, when we should use mode, right? I've already spoken about with respect to outliers and all. Okay. So I'll be giving you important points over here, and this will be your most important points that I really want to mention. Okay. So I will we'll read about this one by one. So I will say, this is my first statement. This is my second statement. Okay. Let me just go ahead, and this is my third statement. When we should use what? Okay. So choosing the appropriate measure, mean, best used when the data is symmetrical distributed without outliers. Okay. When I said symmetrical distributed, your data should be distributed something like this. We'll discuss about it. Okay. What is this symmetrical distribution? So all this kind of discussion will happen in the future when we discuss about the distribution of the data. And this topic will start from histograms. Okay. Provides a mathematical average which is useful for further statistical calculation. Median is specifically used when your data is skewed. Let's say your data is skewed like this. Okay. So this is also one kind of distribution. Here, when we say skewed like this, that basically means outlier is present over here. Okay. So if the outlier is basically present, we'll also be discussing about this skewed data as we go ahead, right? So this basically contains outlier. So in order to provide the middle value, we have to probably use median. Similarly, mode. So here you can see best used for categorical data to identify the most common categories, right? So these are the three types, and when to use what I've already spoken about. Okay. But now let's go ahead and determine the real world applications. Real world applications. And this is what I really want to take care of, because you really need to understand why we are specifically using this. What is the use of using this? Okay. And this is used in one of the very important part of data analysis, which is called as feature engineering. Feature engineering. Let's say you have a data set. You have a data set which has features like age, weight, salary, gender, and let's say you also have another feature which is called as degree. Okay. With respect to age, let's say I have values like 24, 25, 27, 24, 32. There are some missing values also, and there is something like 40. Okay. Then I have weight like 70, 80, 95. Then I have a missing value, one more missing value, 60, 65, 72. Then salary, we have something like 40K. I'll just use this in another color. So I have 40K, I have 70K, I have 45K, I have 50K, I have 60K, I have blank, I have 55K, I have blank. When I say blank, these are missing values. Okay. Then with respect to gender, I have male, female, female, male. Then there are blanks, missing values, and then we have male. Degree, let's consider a degree. We have like BE dash dash PhD, BE, Masters, BSc, and BE. Okay. Now see, observe one thing. When I say feature engineering, what is one of the most feature engineering that you can probably do over here? Handling the missing values. Let's say I want to do one task, which is called as handling the missing value. Now just think over it. How do we handle the missing value for this age column? Let's say if I go ahead and plot this age column, and if I get a symmetrical distribution, then I know I can replace the missing value with the help of mean, right? Let's say if I go ahead and plot this distribution, I get right skewed. That basically means I have outliers. So in order to calculate the mean, I can basically use median, right? And why we are going to calculate this mean and median? Because I want to replace this missing value. So if I try to find out the distribution, if I find out, hey, this is symmetrical, then I can replace this missing value with mean. If I try to find out, hey, if this age entire column is right skewed distribution, then what I can do, I can basically calculate the median. I can replace it over here. Similarly, with respect to weights, why do we do this? This is a kind of feature engineering, right? If I'm having a missing values over here, I need to find out a way to probably replace this. And I know mean median can be applied to this kind of values, and age and weight are nothing but it has both interval, it has that interval scope, right? So here we have already written interval and ratio data it supports. So mean or median I can basically use. If this weight has outliers, in order to replace this missing value, I can use median. Similarly with the case of salary. Now see, with respect to gender, if I want to replace this missing value, what I can basically do, I can use mode. Because mode is suitable over here. Mode is suitable for nominal data. So this is my nominal data, right? Categorical data. Similarly over here also I can use mode. This is also categorical data. So here also I can use mode. Why? Because this degree is also nominal and ordinal. It is nominal and ordinal, right? So here in this particular scenario also I can use mode, because mode satisfies all these conditions: nominal, ordinal, interval, and ratio data. And this is the most important thing while you probably do EDA and feature engineering, right? I have to solve this problem. I have to handle the missing value. And this is just one of the tasks that I've actually told about, and how we can use measure of central tendency to probably implement all these things. So I hope you like this particular video. I hope you were able to understand each and everything out here, right? And this was about measure of central tendency. In the next video, I'm going to discuss about measure of dispersion, right? So yes, this was it from my side. I will see you all in the next video. Thank you.